So we want to consider what an inverse function is, and every function has an inverse, but for that inverse to also be a function, the original function must be one-to-one or injective. Okay, so let's look at an example of what inverse is. So let's say f takes something from over here, x, and then sends it over here. After x goes through the function, it sends it over here to something called y, and this clearly would be the domain of f, all the x values, and this would be the range of f, so d subscript f and r subscript f. So what does the inverse function look like? Well, the inverse function is written like this, f to the negative first power, and it's called f inverse. So anytime you see f to the negative 1, it's f inverse. And what it does is it reverses this mapping. So it takes something from the output of f and maps it back to its input. Okay, so that's f inverse. So now if you consider this over here, this would be the domain of the inverse function because this is the input, and this over here would be the range of f inverse because this is the output. So some interesting things happen here. We can already see that with inverses, the domain and the range swap. Another way to say that is the input is now the output and the output is now the input, so the input and output swap from the original function. And finally, you could think of y as being like the new x for the inverse function since it is the input. So you can also say the x and the y swap. So many different ways to categorize the characteristics of inverse functions. So here's an example with real numbers with functions and their inverses. So what I will assume here is that this function f is one-to-one because of the statement I made up here. The function has to be a one-to-one for its inverse, f inverse here, to be a function. Okay, so we'll assume that. So if you wanted to draw a picture of what this looks like, here's 2, here's negative 3, f does this kind of thing. Takes 2 and sends it to negative 3. So the question is, f inverse then reverses that mapping. So the question is, what is f inverse of negative 3? Well, that maps it to 2. So we can say f inverse of negative 3 equals 2. It reverses the mapping. So notice that the output here is the input here, and the input here is the output here. So you can see how they swapped. So this example is a little trickier because we don't use numbers for the original function f, but I still want to find f inverse of this concrete number, negative 7. So, if we sort of think about this again, so negative 7 is the input to f inverse, and so it must also be an output then of f. Okay? Well, every output of f, this is the general output of f, so every output of f can look like this, so negative 7 can also look like that. So we need to set those equal to each other, and now we can solve for the x here. X is the input to the function f, but it's the output of the function f inverse, so we need to solve for x. Subtract 1 and divide by 2, and we can see that negative 4 is the answer. So in conclusion, f inverse of negative 7 equals negative 4. Okay? Now let's see why this is true. If that's true, then f of negative 4 has to equal negative 7, just swapping the two and using the original function. Well, you can see that if you plug negative 4 into the original function, 2 times negative 4 is negative 8, plus 1 is the negative 7 you get down here. So that's how you would verify it.